Number 3 is not quite done because we forgot to explain our thinking. We talked about it but didn't write it down. How do we know that these are similar? Shh. How do we know these are similar? Good. We know that there's a scale factor. Because the sides are proportional. What else do we know? So we are finishing up 3. Yep, I stopped it a little bit early. We talked about it but didn't write it down. We know these are similar because there's a scale factor, because the sides are proportional based on parallel lines. And what else do we know? What else did we prove here? That, what else do you need for similar figures to be similar? They have to have the same general shape, they have to have a scale factor, and all the what has to be the same size? All the angles must, all corresponding angles must be congruent, meaning they have the same measurement. Good work. So all corresponding angles. So R and U are corresponding. Their measurements are the same because we proved it. S and S, it's the same angle, so it's the same. And then T and V are the same. We could do that for any triangle. 4 now asks you to determine whether those two triangles are the same. I do want you to draw that picture. What do you notice about the line AB and ED? What do you notice? What are those little pink things? Means those two lines are parallel, and that's important. Otherwise we can't use what we know about interior alternate interior angles corresponding in those things. All right, draw the picture. Draw the picture. We are drawing the same picture for number 4. There's one transversal. And there's another transversal. Someone define a transversal for me. So what's a transversal? Because some of you have forgotten what we talked about earlier in the year. You're going to have to remember. Transversal, what is it? Transversal. Anyone? Katie, what is it? Good. It's a line that intersects 2 or more lines. So this line right here intersects this set of parallel lines. And AE right here also intersects the set of parallel lines. Remember, the letters count for the intersections. Okay? The only way to name these angles is to name all 3 parts. You can't just say angle A because we don't know if we mean that one, that one, that one, or that one. Okay? We have to decide if triangle ABC is similar to triangle EDC. So that's the question. What do we have to do to prove that they either are or are not similar? What's the requirement based on our discussion so far today? The corresponding angles have to be the same. You have to have, and actually in a triangle, if you have 2 corresponding, or 2 angles that are the same, the third angle would have to be the same, right? Because we know how many degrees are in a triangle. 180. So you could do the math to figure that part out. So do you see any angles that must match up, that must be congruent to each other? And how do you know? Andy, what do you notice?
The ones that have the red arrows, because the red arrows stand for that they're parallel.
So you're talking about the lines, because you're right, there's like one here, but that would not be an angle. We have to talk, first of all, do you see ABC is right here?
Yeah. And then
And EDC is right here.
they look the same.
They do look the same, so they have the same general shape. Is that enough?
No.
We need
Size and
scale factor and angles. Remember, in a triangle, if all of the angles are congruent, it has to be a scale factor because you would end up making parallel lines and they would be proportional. There will be a scale factor. It works for all triangles. Okay? So we don't have any angles right now that are the same, but we have an awful lot of properties about alternate interior and corresponding and vertical angles. We know from earlier this year some of these angles probably are the same. Which ones and why? Luke.
The two that meet up at C that are outside of the triangle.
So right here and right here, why are those two the same? Why are those the same angle? Yes.
because they're next to each other.
It has a special name when they're opposite of each other. What's that called? One of these words. Are they alternate interior, alternate exterior, corresponding, vertical, or adjacent? Ah, these two are vertical angles. Vertical angles. So, angle BCA is congruent to angle DCE because why? They are what kind of angles? Vertical. Because they are vertical angles. So some of you need to make sure that when you get on Alex and you go to the geometry section that you review those words. Okay? So if I have two intersecting lines, the opposite ones have to be congruent. And we proved that earlier in the year. I'm not going to prove that again. But
So then if it's like that, they're automatically anyway?
no. Right now we only have one set of angles. You need to have at least two more, right? So which other angles have to be congruent to each other? You have two sets of parallel lines. You have a transversal that cuts them. What do you know? A here and D here. Is that what I heard?
Yeah.
Those are dealing with two different transversals. Do you see that? So that won't work. We only do alternate interior, exterior if it's on the same. So if we did, Haley says B, which other one over here would work that's on the same transversal? D. Well, C is no. We already took care of that one. Okay, this one and this one. Why are those two angles congruent to each other? What are they? You're right. They are inside the parallel lines. They are on opposite sides of the transversal. So, angle ABC is congruent to angle EDC. Notice that B and D are the ones that are congruent, so those are in the middle. C corresponds to C if I were going to put those two triangles apart from each other. So I'm listing them this way on purpose. Okay?
I only listed them the first time, but okay. I was just going with it.
Well, I listed B here corresponds with D in this triangle, right? And so you have to list those angles in the right order. They're congruent. Tell me why. Because what? Because they are that angle and that angle. They are what? They are not vertical. No. I know they're corresponding. Why do they have the same angle measure?
They are
Adjacent means next to each other. Interior angles, which kind? Alternate interior angles. They are alternate interior angles. I promise, whatever we have learned in 7th and 8th grade does not go away. The second half of 8th grade melds everything together. So if you have forgotten those terms, that's your homework tonight, okay? If we have two angles that are congruent, what do we know about the third angle? Why? Why does the third set of angles have to be congruent? There's actually two reasons I would take. This one is congruent to this one. Tell me why. Luke.
Because B and D are congruent.
That is not why. Nope. Why are those two congruent? Andy.
Because the alternate angles are equal.
They are alternate interior angles. They are alternate interior angles, or we know that since the inside has to be 180 degrees, whatever's left over would have to be the same. My expectation isn't that you could do this on your own, but my expectation is that you have those terms in your head, okay? And that you can follow this thinking. So, angle BAC is congruent to angle. What's the shortcut for congruent to? Do you guys remember?
It's all
The squiggle on the top? No, it's an equal sign with the squiggle on the top. We could be doing that, okay? D, E, C, because they're also alternate interior angles. Are they similar? Are they similar? Is triangle ABC similar to EDC?
Yes.
Why?
Because all sides are congruent.
Not all sides are congruent. All the whats are congruent? All the angles are congruent. And for a triangle, that's enough. So yes, they are similar because all of the corresponding angles are congruent. You have some homework.
What homework?